Hi, since I'm not in class today, I wanted to walk you through one of your homework problems. We've been doing some work with probability and independent events, and I know some people struggle with this, so I wanted to walk you through this. Alright, so we're talking about a police breathalyzer unit will correctly test positive for 98% of legally drunk drivers. It will also give a false positive reading for 3% of drivers whose actual blood alcohol concentration is under the limit. If 5% of late-night Saturday drivers are legally drunk, an officer arrests 2 drivers with positive readings, what is the probability that exactly one of the 2 is guilty of driving drunk? Okay, so what we're going to do is we're going to break this down using a tree diagram. Now, when I came around, I was seeing people attempt this problem. I noticed people started their tree diagram dealing with the reading, going with the 98%, the 3%. The thing is, they give you the key information at the end of the problem. So we know that this officer is pulling people over on a Saturday night. So first thing we want to know is, what about these drivers he's pulling over? How many of them are actually legally drunk and how many of them aren't? So I'm going to start out with a branch here. And branch in this direction. Now it's telling me that 5%, so I'm going to represent it as 0.05, of the drivers are legally drunk. So I'm going to use D to represent that. D equals legally drunk. I'm going to use probability notation to represent the other people, which is the complement, the people who aren't legally drunk, DC. So if 5% are legally drunk, that means 95% of drivers are not legally drunk. So I'm going to start out here. Now this is where the breathalyzer comes in. I know that it will correctly test positive for 98% of legally drunk drivers. So they pull over a driver. If he's drunk, or he or she rather, it's a 98% chance that they're going to test positive. So I'm going to use P, represent that as positive. Now, if there's a 98% chance that they test positive, that means there's a 2% chance that they don't test positive. So, you notice that this is where I'm starting my branches off. Now, for the next set here, I am going to represent it using, let's see, it's telling me 3% get a false positive reading if they are not drunk. So I'm going to go with 3%. We'll get that positive reading, which means that 97% will get the opposite of a positive reading. So you see that I already have a nice little tree diagram here. Right here I'm representing people who drive drunk and test positive. Here I'm representing people who drive drunk and don't test positive. Here I'm representing people who are legally not drunk or sober, but they test positive. And here I'm representing people who are sober, but they don't test positive. They test negative. So I have these probabilities already. And this represents essentially one driver. You pull over one driver. Okay. So what I'm going to do first is I want to find out the probabilities here. So I'm going to just shrink this down. I don't need that close, and I need my space here. So, all right. So since these are independent events, I just multiply. So I'm going to be plugging these into my calculator. Chances are you might be doing the exact same thing right now. 0.98 times 0.05, and I get 0.049. So that tells me the probability of pulling over someone who is drunk, and I probably shouldn't have used the P, but that's okay, and test positive is 0.049. Probability of pulling over someone who is drunk but tests negative is 0.05 times 0.02. I should probably be able to do this in my head, but I'm still going to use a calculator. 0.01. So I'm looking at some pretty small probabilities here. 0.001, excuse me. Again, I'm going to do the same thing. Probability of pulling over someone who is not legally drunk, but they still fail. 0.285. So again, probability of the complement and testing positive. 0.0285. And if I really wanted to, I could just add these three values up here, subtract it from 100, but I'm still going to do my multiplication out. 0.95 times 0.97, and that's 0.9215. So the probability of a sober person getting pulled over and testing negative is going to be 0.9215. Alright, so that gets me started here. So this represents one situation where people are getting pulled over. Now there are a couple of ways I can approach the next part here. There are a few ways I can do this. Whoops, I didn't want to do that. Looks much better. Okay. What I could do if I wanted to, I could do a whole other tree diagram here, because essentially this is representing one situation. Each one of these represents one driver. I could do this tree diagram off of each of these branches again. Because they're asking about two drivers, so it's probably finding two drivers. So if I wanted to, I could do a nice little branch here, each off of each one of these. Because again, that would represent the second situation. That would be one way of performing this problem, because it's saying probably exactly one of the two that you pull over, this officer pulls over, is driving drunk. So, we could do this for each situation now. This is the probability of someone testing positive, and then for the first time, then you pull over another person. These are all the possible situations that could happen. I could do that off of each one of these. That's going to make a pretty big tree diagram. Bear in mind. But it's one way you could do it. See, I'm going to do that for every single one of these. Tree diagrams can get pretty big, as you can see. So that's one way of doing this. And then I can just look for combinations here that give me a case of one driver, essentially. Paste image. No, I don't want to do that. It's okay. Let's try again. Okay. Crud. Okay, so we're going to do this again. Copy. Alright, there we go. Now I'll try again. Paste. Sweet. So now I want to find situations where we're going to get exactly one person who is driving drunk. I've got one person driving drunk here, right? And I'm going to get one more situation out of that. If I go in my tree diagram here, I can get both of these. Why am I going with both of those? Because that's the probability that I've pulled over someone who's drunk and they've tested positive the first time. So that means the second person that would be pulled over would not be legally drunk. So I'd have to deal with all these probabilities. So then I could just take my 0.49 right here and multiply it by the other probabilities I have present. So I'm going to zoom in as best as I can. So I could do 0.49 times, let's see, this situation here is 0.95 times 0.03. I'm going to plug those in. Perhaps you're doing the same thing. And I got a really low number. And for the sake of what we're doing, I'm going to just round here. So let's see. So the first one I did here was 0.00313. I think it was like 9, so I'm just going to go with 4. I'm going to round it. One way you could also approach this, I've had people ask me this in the past too. Mr. Gamache, do I really have to calculate, let's see, I'm going to make this really fine here. Do I have to really calculate both of these separately? Or can I just do 0.49 times 0.95? And since it includes both of those, can I do that? Absolutely, you can do that. I'm just showing every specific situation. 0.49 times, again, 0.95. And this time I'm going to go with the 0.97 because I'm including that branch. And I get a very, very low value. And I'm going to double check that because I entered in some numbers wrong. Okay, that's better. Alright, so I get this time 0.045. 0.045. And I think it rounds up to 2, so somewhere in that ballpark. All right, so this represents one person getting pulled over and tests positive, and another person is not going to be drunk, so they're not going to be testing positive. So again, I'm only concerned about the people who are testing positive after that one person has been pulled over and I've correctly found him guilty. If you look at the problem here, it says, what is the probability that exactly one of the two is guilty of driving drunk? So again, let's read the question. If 5% of late-night drivers are legally drunk, an officer arrests 2 drivers with positive readings. So we're only looking for drivers with positive readings. What's probably exactly one of the two is drunk? So, this represents all the people in the case right now where one person is drunk and the other person isn't. Now I'm concerned with, let's see, in this case, I don't have to worry about this because all these people tested negative. I don't need this for my problem. I'm done with that. Now I can go down to the second row here, and now it's telling me people who tested positive but were sober the first time. I don't necessarily care about that. All I cared about is, let's see, what's the probability that exactly one of the two is driving legally drunk? I'm only cared about the people driving legally drunk. So let's find out where these people are. So that's assuming the first one wasn't. Now, let's see, if the first one wasn't guilty, let's see who is guilty the second time. These people are. People are guilty. So I want to find the probability of them getting pulled over. 0.05 times 0.98 plus my initial probability here of 0.0285. 0.0014. Seems familiar, doesn't it? It's because we already calculated it. Okay, so those are people who are testing positive correctly. Now, let's see. Is there any other situation? There is. So here's the probability of pulling over that person who does test negative. But again, we got one more person testing positive here. So I do care about that. As it's saying, the probability that if you arrest 2 drivers with positive readings. So again, this person got arrested and they had positive reading. This person got tested, they had positive reading. And this person got arrested and had positive reading. So we're going to calculate that as well. 0.9215 times 0.05 times 0.98. And we get 0.045. So now this deals with all the situations where one person is pulled over and they are correctly guilty. That's all we really care about. One person being pulled over and being correctly guilty. The other ones we don't care about for this problem. So all these other probabilities here, we don't have to deal with it. This just deals with one person getting pulled over and being correctly guilty out of 2. So I just add up my probabilities now. And I'm just plugging them in. Maybe you're doing the same. Right, and I entered in multiplication on my calculator. Luckily I can fix that, right? Plus 0.045. I add them all up. And I get 0.093 or somewhere in that ballpark because I did some rounding. Moral of the story, this is a tough problem. But I want you guys to be able to work with drawing some tree diagrams and finding some probabilities. It got pretty big, as you can see. There are other ways you could have done this. I like visual, that's what I go with. So again, it was just asking exactly when one of the two is guilty of driving drunk. So I just wanted a situation where one of the 2 people pulled over were guilty. You come up with all sorts of probabilities here. It's a lot of different work you could do, but hopefully it at least gives you an idea of one, drawing the tree diagram and being able to calculate some probabilities. If you lost me at the if I lost you rather, at that second tree diagram, right now, that's okay. All I wanted you to be able to do, if you could get this far, that's great. And understand what everything means, that's great. And again, what I just did here was that just represented pulling over a second person. So just repeat the situation, that's all. Alright guys, hope you did okay with it. Hope you're able to follow. And if you have any questions, you know you can always reach out to me. Take care.